All right, so let's just review and talk about some of the more basic things we've learned so far with respect to Java programming. Back in the beginning of times, we talked about this idea of declaring variables, of course, where we have to define the name of our variable and then also give it a type. The name is kind of giving us the location for this variable in memory, and then the data type will allow the compiler, or in the more general term, the computer, to know how much space to reserve for this variable. And so we took a look at integers, right? We took a look at booleans, boolean. We took a look at decimals so far, not decimals. Doubles, which are decimals. And then we took a look at different ways that we can declare these variables. We could stack them up. We could do it in one line. You can assign them at the same time. So int x here, we're declaring it up there, and then we're assigning its value here. Int y equals 30. Here we're doing it in one same line. It is good practice not to have multiple statements be in the same line. So if it's a different statement, go ahead and create a new line for it. And then it's also good practice to comment out your variables. My sample variable y variable y to hold 30. Sorry, this should be x, of course. And then of course we could do multiple ones, right? Multiple line declarations. So int x, y, and z. You can mix and match them as well. So double a is equal to 30 as far as being able to assign them or not assign them, b and c. So just to prove that, we're going to press F5 here and just compile. Again, nothing wrong with setting some of them up initially while you're declaring them in the same line, and then not. So I don't have to declare a value for that. It's not wrong. And then of course we can do some math with these. Let's say x is equal to 34, y is equal to 2, z is equal to 1. We can do things like int sum is equal to x plus y plus z, of course. We can do the product equals x times y times z. We've got our quotients or something, x, y divided by z, etc., etc. And then of course we can mix and match these additions and subtractions. So int random is equal to x plus y divided by z. When you guys are looking at these, of course there's the same order of operation applies to this math as they would in regular math. However, if you do want to change the orders of operations, much like you would in rewriting these as a fraction, you could force it that way. So you could force this to be the numerator of this entire fraction by just adding these parentheses, and then the order of operations will then, of course, still be followed. So again, you can change the order of operations by doing the parentheses. Otherwise, this would have done x plus this fraction rather than adding x and y together, had we explicitly determined that by adding the parentheses. So there you go, some math that you could do. Some of the variables we have seen so far, we've seen Boolean, integer values, and decimal values. Alright, and then so now let's move on to some of the other things we've seen. You guys have seen, of course, the outputs, but that shouldn't be on the tests, or yes, the test. So now let's take a look at the if statement. The if statement, of course, is also called the conditional statement in Java programming. The if statement is found in pretty much every other programming languages out there: C, C++, PHP, Visual Basic, all those fun languages. And so we talked about this idea of a reserved word in Java, where Java has determined a special function for it. In this case, when you've got an if statement, of course, the if is a reserved word. And then this is the way of writing it. You've got your if keyword followed by your parentheses where the conditions will be written. And then finally, you've got the code that will run here. Code here. So, you know, if you're being technical, essentially you don't need those curly braces there as long as there's only one statement that will run for that if statement. However, because everyone's kind of like a newbie programmer, let's not take the chance. We can do that later. We can talk about some of those shortcuts and things that you could do to clean up your code. But when you've got your if condition, your if statement, you've got the setup to look like this. Again, your if keyword followed by conditions, and then the code will run if this condition is true. And of course, you can have an if else here. Run code if condition is not true. So you want to do an if else if you've got two choices or two different pathways for that logic. Otherwise, you can do an if else if block, if else if, and then else. So you could have something like that. And of course, as far as indentation goes, you want to indent code that will be inside this if statement. So all the code will run here. So let's say we've got an x value up here, x is equal to 0. If x is less than or equal to 0, for example, is our condition, then we're going to go x is equal to 1, x is equal to 2, x is equal to 3. So as you can see here, all the code is indented within the curly braces here. Your white space does not matter, but again, by convention, do not do something like this where you have multiple statements in one line. Go ahead and create a new line for them. Variable x, and of course, when you guys are wanting to comment, you've got your double backslash there. All right, so let's talk about the flow here as far as what will happen with the code if a condition is false, if condition is true, etc. So again, we have an if statement. This if statement says if this is true, run all of this code down here. Again, the code that will run is determined by our curly braces. If this code was outside of that curly braces, of course, it won't necessarily run in there. It might run later. But again, if you want to protect this code, if you're saying this code should only run if this condition is true, then you put it all inside the curly braces for when the condition is true. So again, if condition is true, then we will be running this code. Otherwise, you'll run this code. So essentially, you don't have to check whether or not that condition is false. If that condition is not true, then in this case, it's false automatically. We know that if it's not true, then it's going to satisfy this other condition that it's false. Therefore, we'll run this code down here. And then, of course, you can make additional decisions. So, for example, if you are making a decision on x, and then you've got another variable y, then in here you can write another if statement. So you're going to go if y is not equal to 0, then I'm going to do something cool, else do something. So this is the equivalent of writing this all the way up there. In one statement or something, you're going to go, all right, if x is less than or equal to 0, I'm going to make a decision. My second decision is going to be if y is not equal to 0, and then we do something else. So again, I'm just showing you different ways that you can nest these. Whenever you have an if statement inside another if statement, of course, you are nesting those if statements. So yeah, if you guys want to simplify your lives and you don't want to keep tracking these, just make sure to, go ahead and write the bare bone for the if statement and then fill it in later. So int. Let's see, so that was the if statements there. Again, it's going to allow a program to choose whether to execute a particular statement or set of code. And then the indentation, again, is important for readability, especially later on when you guys are sharing code. So now let's talk about the different operators, again, that we've seen so far. We've got our equality operators and relational operators. And of course, our relational operators will let us decide the relationship between values. So for example, if x is less than or equal to y, then so here we are trying to block this code from running unless this is true. So again, if I changed it so that x is not less than y, then this is not going to run. So again, sometimes they call them a blocking statement because again, this code will only run if this is true. And of course we can have multiple lines here. Yep, like that. And then of course we've got other statements. Greater than equal to, again you write them as you would say them. X is greater than or equal to y. You can have the plain greater than and then the plain less than. And then you've got your equality operators. You've got your equals equals and then not equals. Again, you write them as you say them. And of course, you don't want to have an assigned statement over here. I can't tell you how many times my students have done that in the past. And of course, there are some, IDEs out there that will actually allow you to compile if you don't set any warnings or errors for this type of error. But many times this will be a logic error anyway, so it's not something that you'd like to do. Can you force this? Can you make it work? Yes, especially if you're working C, C++. This stuff is completely legal, but it's not something that you usually want to do, and it's not really considered good coding conventions anyhow. So try to avoid this for now, and then of course later on as you guys are learning to program and are becoming experts, you can do more. But for now, because I don't want to track all of your code, of course you don't want to do that. Alright, so we've talked about our equality operators and relational operators. Again, all of those things that I've shown. Equality operators being equals equals and not equals, and then our relational operators being less than, greater than, less than equal to, and greater than equal to. Alrighty, so again, if statements can be used as blocking statements, so we haven't done much with them, but we will in the future, because again, we'll just be stacking onto whatever programming knowledge we have now. And then of course you can have nested if statements. Whenever you have an if statement inside an if statement, you've got a nested if statement. And then of course, just in case you were curious, you can also have more than 2 branches here. You can have an unlimited number of them if you really have that many conditions. So let's just go wild here. So now you've got something like that. I can have an if statement here. And then of course I can have one within that one, within this one, and then within this one. So you get the point. All these are different pathways, different control flow. And then of course within that pathway you can have another set of decision making. So logically speaking, that should make sense, although it seems intimidating now just to have all of those. Of course, you shouldn't find that too hard to believe that you could have all those things. Some of you guys try to do that a lot in coding bad, and yeah, it gets crazy. It does. Alright, so now let's talk about our Boolean expressions, right? We have logical operators. Those are going to be the logical operators. We've got our not, our or, and of course, we've got and. Make sure you know how to write them. For an or statement, of course, one of the conditions must be true for the entire statement to be true. And then for the and operator, both conditions have to be true. So as simple as that. We didn't go over our incrementing and decrementing operators. We will do that as soon as we start learning more on loops. But, you know, baby steps. There's a lot of information in chapter 3 alone, and at this point in time, my job, well, I'm trying to make it my job, right, is to at least make you guys feel comfortable beginning to write code from scratch. And so I'm trying to give you as much as I can without overwhelming you with all the minute detail related things. And so I'm just having you guys focus on the main structures of programming so far. So I believe our last topic that we covered would be the while loop. While loop, of course, is very much similar to an if statement, except for the fact that it repeats over and over. So you've got your if statement there, my while loop. My while loop requires a condition to run. Conditions. Of course, you can have multiple ones there. Same thing for your if statement, of course. Conditions. And then code that runs if conditions are true. Same thing for your while loop. Here are your conditions that will run if, your code that will run if the conditions are true. So again, same thing here as far as your block of code. Again, we are using our curly braces here to help us see that this is the code that will run, provided that that condition is true. So let's go ahead and make something happen here. We'll just make it count or something. While x is less than 5, we are going to say system.out.print. We're just going to print out x here, and then we are going to increment x. This idea of incrementing x just means, of course, you increase its value, and so that's all we're doing there. And then here is my output. And of course, you can have an infinite loop. Well, is it useful? I don't know. Depends what you're doing, I suppose. So, for example, you can have while 1 equals 1. Is there ever a time when that is not true? Let's see what happens. So as you can see, it's counting, and if you actually make it count high enough, you'll either freeze your computer or you'll hit overflow, which is, if you hit the maximum number that an integer can hold, a 32-bit number, 32-bit signed number, then of course you will see some overflow and it's going to go crazy. But again, that's another topic to revisit later. But I'll end the video here because the computer froze. Didn't like my while loop at all. No. So, darn you, JCreator, right? As you can see here. Alright,